Hello guys, in this video we are doing complex numbers. A complex number is the square root of those negative numbers that we have been saying is undefined in the previous grades. For example, square root of minus 1, we're saying it's, if you punch it on a calculator, it gives you an error. So in this video, we want to see how to simplify those type of numbers that we call complex numbers. So complex numbers, we have I squared is equivalent to minus 1. So to find this one, to find I, we must apply square root on both sides, which is the square root, square root. Therefore, I is equal to square root of minus 1. So now we know that square root, it's minus 1 here. So now we know that square root of minus 1 is equal to I. So let's see how we calculate the square root of minus 4. Square root of minus 4. This one is equivalent, minus 4 is equivalent to 4 multiplied by minus 1. So we have square root of 4 multiplied by square root of minus 1. So the square root of 4 is 2. And the square root of minus 1 is equivalent to I. So now we can find square root of any negative number. Let's give another example. Square root of negative 81. This is equal to square root negative 81. Let me put a negative inside. This one is equivalent to square root of 81 multiplied by minus 1. 81 multiplied by minus 1 is negative 81. So this is the square root of 81 multiplied by square root of minus 1. The square root of 81 is equal to, this is equal to 9. Then square root of minus 1 is equivalent to I. So square root of negative 81 is equal to 9I in complex numbers. So complex numbers, they consist of real part and imaginary part. So we have real and imaginary. So imaginary part is this one. Then the number that consists in I is what we call imaginary part. E.g., we might have a complex number 1 plus I. This one is our real part. This is our imaginary part. So complex numbers can be represented in many ways, in 3 different ways. So the first way is called the rectangular, which is this one. So let's see those ways of arrangement or of representation of complex numbers. Before going to different representation of complex numbers, let's see how to represent a complex number on an Argand diagram. So this Argand diagram is like this. It's a Cartesian plane. So where we had x-axis, this represents the real part. This one is the imaginary part. Imaginary part like this. So let's have an example. If we are given a complex number like 1 plus I, e.g. 1 plus y, 1 to represent it on an Argand diagram. How many units do we have in the real part? It's 1. Then how many units do we have in the imaginary part? We check the coefficient of I, it's 1. So we have 1 here as well. So we can mark it I. So at this point, our complex number starts from this point going that side. So we have this angle that it opens, which is theta. So that angle, it have a special name, is called argument. So theta represents the argument of a complex number. So whenever you see a question saying calculate the argument, it is asking you to calculate that angle theta. So this part is I, this is 1, Then we have this part which is r, the modulus of this small triangle that we are forming. So to calculate that modulus, we need to use Pythagoras theorem, since we have 90 degrees there. So we can apply Pythagoras theorem to find the value of r. So let's see how we find the value of r. So r squared is equal to, this one is 1 unit from here to there, 1 unit from here to there, 1 squared plus 1 squared. So r is equal to square root of, what is 1 squared? Is 1 plus 1, which is equal to square root of 2. So r is equal to square root of 2. To find theta, we use the trig ratios. Trig ratios, we can use these two known sides. One, which is our opposite side, this is our adjacent side. So opposite of adjacent is equal to tan theta. Therefore, tan theta is equal to 1 over 1. So tan theta is equal to 1. That's equal to 1. Therefore, theta is equal to tan inverse of 1. Tan inverse of 1 is equal to 45 degrees. So that 45 degrees is equal to theta, which is the argument of our complex number. Now let's see forms of complex numbers. So we're gonna use the example that we used in the previous video, in the previous part where we have been doing presentation of complex number on an Argand diagram. So complex numbers can be represented into 3 different forms. Number 1 is called rectangular form. This is the one which is similar to what we did on the previous section, which was 1 plus I. That's what we call rectangular form. Then we also have polar form. Polar form is in this form: r cos theta plus I sin theta. Then we also have third form, which is called exponential form. Exponential form is r multiplied by e power I theta. That's exponential form. So according to that one that we used, we said rectangular form is like that, 1 plus I. So we want to see how to represent this 1 plus I into polar form and exponential form. So let's see polar form first. We calculated our argument. Our argument was 45 degrees. And our modulus r was equal to square root of 2. So to represent that in polar form, it becomes, you can say 1 plus I is equal to square root 2, because it's in the form r cos theta plus I sin theta. So we have r root 2 cos theta is equal to 45 plus I sin 45 degrees. That's our answer. Now to represent the same complex number in an exponential form. So exponential form is equal to, this is equal to RE power I theta. Our R is equal to root 2 e power I, then theta is equal to 45 degrees. So we have root 2 e power 45 degrees R. That's our answer. So this is how we represent complex in 3 different forms. So if you are given a complex number in exponential form, you must know how to change it to rectangular form. Also, if you are given an exponential number in a polar form, you must know how to take it to exponential or to rectangular form.